Hi, we're going to go over some normal distribution questions and a question on comparing distributions. So the blood cholesterol reading for a group of women are normally distributed with a mean of 172 and a standard deviation of 14. We want what percent of women have blood cholesterol reading between 158 and 186. So I'm going to draw the information we're given. That's a normal distribution. The mean is 172, so in the center, and the standard deviation is 14. It says to use the empirical rule, and that's where we count 1, 2, and 3 standard deviations in each direction. So if we keep adding 14, so if we go one standard deviation away from 172, we add 14, we get 186. And then if we add another 14 and go 2 standard deviations above the mean, it's 200. And if we add another 14, we go 3 standard deviations above the mean, that's 214. And then now I'm going to subtract 14. So 172 minus 14 and go 1 standard deviation below the mean, and then 2 standard deviations below the mean, and then 3 standard deviations below the mean. So it wants to know between 158 and 186. So that's from here to here, and that's 1 standard deviation away from the mean in each direction. And according to the empirical rule, that's 68%. So 68% is our answer. If it was 2 standard deviations from the mean, that's always 95% according to the empirical rule, and then 3 standard deviations from the mean in each direction is 99.7%. Okay, this one is the same information, so it's saying it's still a normal distribution. The mean is 172, and the standard deviation is 14, but it says instead, what percent of women have a blood cholesterol reading of at least 180? So 180 is above 172, so I'm just going to mark it somewhere over here. And then we want what percent are at least 180. That means 180 or more. So we want to find this area, that percent, and we're going to use the z-score table. So that means we have to find the z-score first. The formula for a z-score is the value that we're looking at minus the mean divided by the standard deviation. So it's going to be 180 minus the mean, and that's because we want to see how far it is from the mean in terms of how many standard deviations that is. So we divide by what the standard deviation is. We get 0.57, and what that means is 180 is 0.57 standard deviations above the mean. Then we go to the z-score table and we find 0.57, and then that'll give us the area that is below that value, and then we're going to have to subtract it from 100% to get above that value. So I'm going to go to the table and look up 0.57. And 0.7157 is this area, or 71.57%. So when you look up a value or a percent in the table, it's always going to give you to the left of that z-score. And we want to the right, we want the shaded area above it. So we do 100% minus 71.57%. And then we'll get our answer, which is 28.43%. Okay, so this is the same situation. It says normally distributed, the mean is 172. I'm going to draw this again. And a standard deviation of 14. And it says 65% of women are below what reading? So we want to find a value on our number line where 65% is below that value. For example, 50% is below 172 because it's right in the center. 65% would be below some value greater than 172. We're trying to find some value here where 65% is below that value. So we're trying to find that value of x. So what we could do is work backwards and use the z-score formula and figure out, plug everything in and figure out what that x value is. So we don't know what x is, that's what we're trying to find, minus the mean divided by the standard deviation. We also need to plug in a value for z so that we can solve for x. So the way we get the value for z is go to the z-score table and look up in the table what value of z gives us 65%. So I'm going to plug in for z 0.39. I'm going to multiply both sides by 14 because I want to solve for x now. And then I'm going to add 172 to both sides. I get 177.46. So what that answer means, that's the number here. And 65% of women have a blood cholesterol reading of 177.46 or lower. Okay, so I want to look at where the z-score is positive 0.57. So I'm going to go to this part of the table. Here's 0.5, and then this would be 0.51 or 0.50, 0.51, 0.52, and so on until I get to 0.57, where it says 0.07 up here. So I want this number, 0.7157. Okay, so I'm going to go back. Okay, so I'm in the, let me just show the whole table. I'm going to find in the table, instead of looking at the z-score, I'm looking within all the columns, rows and columns, to try to find 65%. So I know it's a positive z-score because it's above the mean. So I'm going to look over here, and I'm just going to look at these values and look at the number that's closest to 0.65. And it looks like here is the closest number to 0.65. So I'm going to use that one. So that z-score is 0.3, and the hundredths place is 9.39. Okay, let's do one more, and the solution's already here, but I want to go through it. So it says a psychologist is studying how spending time outdoors could impact your mood. They surveyed 2 samples of people, and the results are displayed on the dot plots below. Compare the distributions. So anytime you are comparing or describing a distribution, then the thing that we remember is SOCS. And we also want it in context. So you're writing complete sentences, you're not just making a list of numbers. But SOCS is how to remember what to include, so we'll go over that. So it says both distributions of mood level are skewed left. That's the shape. So you need to compare their shapes. The way we know they're skewed left, if you just kind of like draw a line, picture like a blanket or a sheet is covering the distribution, there's a tail going to the left. And then same with this one. So if we just kind of like cover that up, there's like a peak kind of to the right and then a tail going toward the left. The median of the outdoor group is 7, which is larger than the median of the indoor group. So median is a measure of center. So you're saying what the centers are and comparing them, because it says compare. Compare means you actually compare things. You use comparison words. You say things like less than, greater than, larger, smaller, equal. That's what compare means. The range of the outdoor group is larger. So range is a measure of spread, how spread out the values are. Range is usually the easiest one to do. Range is the difference between the lowest and highest value. So the range of the outdoor group is 10. That's because it starts at 0 and ends at 10. If you subtract 10 minus 0, you get 10. With possible outliers of 0 and 1, it's talking about these values here. And then the range of the indoor group is 8. So that's from 0, it's because it goes from 0 to 8. And then because of the outliers, the standard deviation for the outdoor group is larger than the indoor group. Standard deviation is another measure of spread. You don't have to do both. It just had that in this solution, it did both. But standard deviation is just another measure of explaining how spread out the values are. It's the average distance each value is from the mean. So we also included outliers. If there aren't any outliers, then you don't have to mention it. So shape, outliers, center, spread is what you need to include when you're talking about distributions. And then context means you're talking about what the scenario is about. So in this case, mood level is the context. And then again, actually use comparison language. So like larger, they use the word larger than. You can say less than, greater than, smaller, equal to, some sort of words so that you're actually comparing the distributions.